we will start our part 3 of our learning. Now, as we check that we have several types of machine learning. So now, as a beginner, we are planning to focus on supervised machine learning and unsupervised machine learning. So maybe you remember unsupervised machine learning is the unlabeled data. Can you tell me what was the unlabeled data? Can you tell first? It's okay, you can tell in Korean also.
Very good. 식사, 식사, 100%죠. 어렵네. 정말 어려워.
I don't know really sure what he said. Jigsaw. He said like the difference about the
type.
tendency.
Okay, when I came here, when I came in the lab first, I did not know your name, any of your names. I do not know who is the master student, who is the PhD student, who is the undergrad student. So that time our lab was an unlabeled data for me. I am watching the data, I'm watching the person, but I do not know who is who. But now I know. So now you are label data for me. So you understand? Well, I first came, I was learning about you. That was unsupervised learning for me. And now I know about you, who you are, your grades. So now this part is supervised learning. Okay. So you remember we saw this in our last lesson. So if a new data came, then how we define which cluster the new data will go?
Oh, we can calculate the distance.
Can you go to the board and do this?
Yeah, sure. Yeah, let's go. If new data came to here, and the distance between this data and the central of another check this distance.
How we will check the distance?
So can you mute? We can use the Euclidean like choose the shortest one, the minimum.
Yes.
Yes.
So he wrote x1, y1, x2, y2.
Oh.
Yeah. You understand what is x1, y1, and what is x2, y2?
X2, X1, and
Can you explain to him what is x1, y1?
그 적극평면에서 거리를 계산하는 거랑 똑같은 거지. 그냥 거리 계산, 점과 점 사이 거리 계산. 그냥 유클리디안 거리가 이런. 네, 그냥 비슷해.
Last day I skipped this part, but I was thinking that you guys will ask, but you didn't ask me. That's why today.
Okay.
So you remember the picture, right? You remember. So you created the clusters, and we also got the centroids. But with the data, we created 4 clusters. We can see different 4 groups. Okay. But now you tell me that how we are fixing the number of clusters or how we are fixing the value of k.
Answer.
Yes.
Tell the answer.
Yeah.
Uh, you can use method to choose EK or heuristically. Heuristically.
What do you think?
K something.
Data distance average.
Yes, but see, you made 4 clusters. So why we made 4 clusters? We can make 3, 2, 4, 5, 10.
왜 4일까? 5도 놓을 수 있고 10도 놓을 수 있고.
So the answer is we choose optimal values for k. Suppose we are going somewhere from our lab. So we are including our professor, maybe we are 10 people. So how many groups should go? Maybe we can go by 2 cars. If we are planning to go only 2, then we need 5 cars. So which will be optimal? Going in 2 groups or going in 5 groups? Which will be good? Going in 2 groups. Okay. So how we are fixing this? It will decrease our cost, it will save our time, and it will also make that nobody will be lost.
Yeah.
Everyone will be together. So like this, we also choose the value of k for our clustering optimally. So for these things, to find the optimal value of k, we have 2 methods. One is elbow method and another one is silhouette method. So the most popular one and easy one is the elbow method. So first we will start with the elbow method. You know what is elbow? So what elbow method in our K-means clustering is, where we start randomly, we start putting the value of k randomly, like from 1 to 10. Like first we will start to think how should we go. We should go 1 people, 1 people, 1 people, 10 people by 10 cars, 2 people by 5 cars, 3 people by 4 cars, like or 5 people by 2 cars, or 10 people by 1 bus. Okay, we will start thinking like this. So this is how we will also work in our elbow method. For the value of k, we will start taking value from 1 to n. N could be, it depends on our data, how big data we are using. Such as I am using 50,000 SSD data. So my n, the value of my n could be 50. I could divide my data into 50 groups. Okay, but if I am only working with 100 data, I have only 100 data from 100 SSD. So it is okay if I make 10 groups. So the value of n also depends on the size of our data set. Okay. You understand?
Yep.
You?
뭐,
So suppose I have 500 data. Then I can make 50 groups, 50 clusters I can make. But when I have 50 data, only 50 data, 50,
Yep.
then should I make 50 groups? Should I make? I have only 50 data. Yes, 50. So how many groups should I create? 50? Then it will have 5 data. It will be more easy to learn by mimicking. Okay, so the value of n depends on the size of our data set.
But is it only depend on size of the data? It depends on.
Okay, because we will do the elbow method to
Mhm,
find the value of k.
mhm.
To find the value of k, we need to make some groups. and which group will give us the smallest distance, we will choose the value for k
Mhm.
for our full process.
Mhm.
So I will go in the next.
Yeah, okay. Yeah.
So this is the main formula for alpha method.
Mhm.
You know this formula?
Yep.
You know? You know? You know?
Yeah.
Can you explain if you know? It's okay, you can try.
It's literally the sum of squares.
Yes, but I mean, you know the formula.
But not the error, squared error between points and sum of calculation. Is it math? I don't know.
Okay. So for this, we will need to learn from here.
Okay.
So maybe I will
Okay.
help you to learn. Maybe you will understand.
Let's go.
So this is our data set. Like suppose we have this much of data from our data set. So for what we said that we will set the value of k for 1 to n. So for this much of data, maybe we can set the value of n to 3. Okay. So first it is 1. So if the value of k is 1, then we will have only one cluster. So this will be our centroid. So it has x1 and y1, and maybe this is our data. So maybe it will have the value of x2, y2. You know what is x2, y2, right? So we can calculate the d. So from here we will get 1d, and if we, how can we go to my previous slides? To go to the previous slide.
I think, but you need to you need to
D,
deconvert.
yeah.
You need to
Deactivate the mode.
yeah.
Yeah. The,
You need to yeah.
Can you
그거 그쵸.
I never use this too much again. So we set the value k for 1. So we have one cluster, one centroid. So we are calculating our d. Maybe it's d1. So we saw the formula WCSS equals to sum of d square. So we have one here, the value of k is 1. So we have only one cluster. So we have only one d. So maybe we are getting here the d for 500. Okay. So, and then if now we will set our value of k equals to 2. Okay. So here we will have two clusters. If we have two clusters, then how many centroids we will have? Two. So this is one, this is another one. So now here we will calculate d, or maybe our d1, and here we will calculate our d2. And then we will calculate our WCSS, which will be d1 square plus d2 square. Okay, this is the sample, but we need to calculate all. We need to calculate the all. And then we will do the sum here. Okay. So here we will get our WCSS2. And then when our k equals to will be 3, we will maybe make 3 groups. When we have 3 groups or 3 clusters, we will have 3 central. Okay, again, we need to calculate the D's. So when our K equals to 3, our WCSS will be summation of D1 square plus D2 square plus D3 square. So maybe for this, we will get the score of 300. Okay, so now we have K3, our 3 is 300 for K2, our WCSS 2 was 50, and for when K equals to 1, then our WCSS 1 equals to, suppose they are imaginary values. We are not calculating, so they are the imaginary values. Okay, so like this, maybe we will have more values. Then what will we do? What mathematically we do, or our machine, our model will do, is it will make a graph. Here we will have the number of clusters or the values of K, which started from 1, 2, 3, 4, 5, 6, like this. And this is our which axis? Yes, this is our x-axis. And our y-axis will have the values we calculated WCSS with the big formula. So we will have them here. So when our K was 1, our value of WCSS was 1000, right? When it was 2, maybe it was 700. When it was 3, it was 500. When it was 4, it was maybe 400. When it was 6, maybe it was 300. And then maybe where it's going, it will go 100 and like this. So here we will get a shape like our what?
Our elbow.
Yes. So this point, we will compare this point. This could be our values of K. So our values of K could be 4 or 5 or 6. Okay, you understand?
Can we choose 100?
No, we cannot go, we cannot choose the value, because we cannot choose the upper one and we cannot choose the lower one also. We need to point the elbow. That's why this is called the elbow method.
I mean, but what is the criteria for choosing 300 rather than 100?
Because it's in the, when we are comparing it, it's in the middle. So
Middle.
the mid value. So machine learning is biased with the mid values. So that's why. And when our curve is not pointing, we can choose 2, 3 values, and then we need to predict. So that time we need to check with 4 clusters, with 5 clusters, and with 6 clusters. The value, which one will give us the best result, we will accept that one. Okay. You understand?
So, yeah, I understand. My question was actually I'm a very beginner of this kind of method. So I think the stabilize the slope is the 100, because that slope is the kind of the
We will
yeah, but this area is the stabilized area.
yes, when we were going to more clusters, our machine will start predicting wrong, because if we have this much of data, and if we have so many clusters, so when our new data will come, so it will give same values for more.
I see.
So that's why we cannot choose the lower values. We cannot choose the higher values. We always go for the median, I mean the midpoint value.
I see.
So this is.
Wow. Yeah, good explanation. Good teacher.
So this is how we will get our curve for elbow method. And then by watching this curve, can you tell me which of the value of K we should use? 2, Y, 2, 3, 4. Yeah, we have 1, 2, 3, 4, 5, 6, 7. Which one should we take? Just compare with your elbow.
Two.
Yeah, 2, but 3 will give us more better result. Okay. So, but in real life, while you will practice, we are not working with short amount of data. We are working with big size of data. So that time our card will be more bigger. So that time we need to make our model think more smartly. So see, but how we are pointing. So okay. So now I will go to the codes. So here you will find the today what we have learned. You will find it in the codes. You can make the card by yourself by running this code. Did you understand where we have? We also put the data set here. You made the clusters here. So by running these codes, you will make the cards today and find the value of K from our code. And also we have some questions here. They are not too much, just they are just translation.
Okay.
So I think after that, we will learn one algorithm for supervised learning and one algorithm from unsupervised learning. Maybe we can find small data set and we can implement. We can do our experiment with machine learning if you want.
They should want.
I don't do it. I don't do it.
And then maybe we will implement KNN and kmeans with the data set. After that, we can learn the decision tree, the random forest, this type of data set. This type of algorithms, actually, we do not need to learn too much. We just need to learn how the algorithm works. And we just need to use the data set. And we just need to know how to use the codes for implementing the models. This is what we need to do in our machine learning. The main thing is the data set. So if we work with the data set with the model, we can learn the data set well. And first we can start with very small data sets. We do not need to validate. We do not need to outperform previous work. We just need to learn how to work with the data set. And we have so many, like the SSD data set I am working, it is so big, we can just make some small groups and try by ourselves. If you want, and if you are interested, maybe we will go for our next steps. But before that, just run this code, go through today's slide and give me the answers.
Okay.